Hello, welcome specially to the Engineer Construction Lecture Hall, always a platform where you get vital updates as regards to construction. All right, so today we are going to look at a very important and interesting topic as regards to construction. So we are looking at a very vital material that is very indispensable, in carrying out our construction work. So we are going to look at we are going to discuss basic features basic features of rebars. That's our topic for today. Now when we talk about rebars, we are referring to reinforcement steel bars. All right, now the re is the reinforcement bars. Okay, so now we have to, for us to do our construction, and as you know, majority of our structures are reinforced concrete structures. Now reinforced concrete structures are those structures that comprises of your reinforcement steel bars and your concrete. Now it is the reinforcement that forms the framework of that component, while the concrete provides the coverage. Okay, concrete provides protection to that reinforcement. All right, so it is important that when we are carrying out our construction work, we must look at certain features, as regards to our reinforcement, because quality is a very important parameter when we are dealing with construction, because whatever that goes wrong in the course of construction most times is traceable to poor quality of materials, and reinforcement is one of the materials we use in construction. So we have to look at certain features, all right, to judge or to assess the suitability of that reinforcement for that particular construction work. Now I want you to understand that in construction, prior to construction, we do design. Now the design, there are parameters we design with. One of such parameters is the diameter of reinforcement. Now the diameter of reinforcement, if we use a particular diameter, we design for that diameter of reinforcement. It is important that during construction you conform with that diameter, because most times you see that structures are compromised, all right, by not using the designed diameter for that particular structural element. All right, because it's expected that whatever we have designed while carrying out construction, we should do our construction in conformity with what our design has provided. All right, so one of the basic features we look out for in our reinforcement is the diameter. Okay, diameter of rebar. Okay, diameter of rebar. Now diameter of rebar shows we have our reinforcement this way. Okay, the diameter now is the distance from this outer part to this outer part. That's the diameter, D. Okay, so we have various diameters of our bar. We have 6 mm, we have 8 mm, we have 12 mm, rather we have 10 mm. Okay, we have 10 millimeters, we have 12 millimeters. Okay, we have 16 millimeters, we have 20 millimeters, we have 25 millimeters, we have 32 millimeters, we have 40 millimeters. Okay, these are the various sizes or diameter of our reinforcement. So it is important that whichever diameter we are using, now all of these diameters have their various areas where they are used in our structure. Okay, our structure in this context, I mean, we have different structural elements that makes up a structure. Okay, so these various sizes of reinforcement is a kind of suitable, in different areas of those structures, just like in our human anatomy. we are human anatomy is made up of the bone structure, the bone frame structure. Okay, now that bone structures have different sizes, so there is no way you can have a particular size of reinforcement used in the entire structure. Okay, so these different sizes have their various areas where they are adopted, and basically we have to design for those various structural elements to enable us use any of these sizes of reinforcement for that element. So the diameter of our rebar is very important that we look out for. Okay, and how do we verify the diameter of our rebar? We can use our vernier caliper. Okay, we can use our vernier caliper. Okay, vernier caliper. Now our vernier caliper uh, gives accuracy in terms of to determine the diameter of our reinforcement. All right, you can also use micrometer screw gauge to also determine the diameter of our diameter. So it's important for a good quality control practice. During the purchase of our reinforcement, you can go with your vernier caliper to measure the diameter, to ensure that the diameter that you're going for actually meets up to standard, because most times you see that the reinforcements we have in the market, these days we have different types of reinforcement in terms of their brands. Okay, and the diameter also in some of these brands, you see that the diameter is not up to these various sizes of diameter stated here. So with your micrometer or vernier caliper, you can be able to determine the diameter of these various sizes of reinforcement. All right, so another feature that we are expected to look at is the length of bar. Okay, the length of rebar. All right, I know the length of rebar by standard is 12 meters. Okay, 12 meters or 40 feet. Okay, 12 meters, 40 feet. Okay, by length. All right, so but you see that most reinforcements we have are less than this length. Okay, but we must also look out for this length, because this length enables us in terms of calculating the quantities of reinforcement for our structure. So if we are dealing with the standard length, it will give us a clear quantity for our for that structure. All right, so we have to look out for the length. So how do you measure the length? Is by stretching, or a kind of stretching the reinforcement. Then you can do your measurement, your linear measurement, to ascertain the actual length of that rebar. All right, so length of rebar is one of the features that we have to also look at. Then we also look at the surface. We also look at surface roughness. Surface roughness. Now, surface roughness here talks about the deformation. Okay, in our reinforcement we have what we refer to as high heel steel. We have mine steel. Okay, mine steel are usually those reinforcements that have a smooth surface. All right, why high heel steel are those steel that have, okay, one of the distinguishing feature is that the high heel steel has a deformed surface. All right, which is what we are talking about. Then in terms of the tensile strength, they also differs. We'll come to that as well. So the surface for the high heel steel is a deformed surface. We will be having something like this. Okay, we'll be having something like this at the surface. Okay, now this is the deformed surface. Now this deformation enhances proper bonding. All right, it enhances better bonding, because reinforcement and concrete, they have this mutual compatibility. Now it is this deformed surface that also enhances the bonding strength that should exist between your concrete and your reinforcement. So I want you to take note of that. So surface roughness is very, very important that we look at it. Now you see in some brands of our reinforcement, you see that the roughness is mild, okay, is mild, and you see it more. All right, so these are some of the things you have to look at, because if you have more of the corrugated surface, it will help to enhance better grip, better grip internally, because when the concrete is being, once the reinforcement is covered by the concrete, there should be this grip that should exist internally. All right, so you see that most times you see the reinforcement slipping internally, and that can result to vibration or resonance in our concrete structures. Probably you might see some structures, slabs, you get on it. By the time you step on it, you start feeling vibration. This can also, attest to that fact there is a kind of internal dissociation, all right, that has existed. All right, so we have to look out for surface roughness for our reinforcement. All right, then we also have to look at the tensile strength. Okay, the tensile strength. All right, the tensile strength. Now, tensile strength is the actual strength of our reinforcement. It is the makeup, the tensile makeup, strength makeup of our reinforcement. Now, we can have the same tensile strength for this whole reinforcement, but the diameter now will now, the higher the diameter, in terms of the higher the strength, compared to the lower diameter. All right, but they can be made up of high heel steel. All right, so it is only the diameter that differentiates them in terms of their ability to withstand load. All right, so the tensile strength talks about the build-up, the mechanical build-up of that reinforcement. All right, the material strength of that reinforcement. That is what the tensile strength measures. Now, for my steel, like I said earlier, for my steel, we have my steel. Okay, my steel is 250 Newton per millimeter square. While our high heel steel, okay, our high yield steel bar, we have 410. Predominantly in this part of the country, we have more 410 per millimeter square, but it gets to 500. We also have 500 millimeter square. Okay, as the case may be, it can be higher than this as well. All right, depending on the area where that steel is to be used. All right, we can have this as their tensile strength, but in terms of the diameter, it can differ. All right, so that is the tensile strength of reinforcement. Then we also have to look at the identification. Okay, the identification of the manufacturer. Okay, we have different manufacturers. The different manufacturers details. Okay, we have different manufacturers. Okay, so when you get to where you intend to purchase, you will see different types of reinforcement. That is the brand. All right, but you can see the same diameter, but the brands or the manufacturers details will be different. Okay, so but all we need to look out for is these features, especially the diameter. We must ensure that we have the right diameter of bar, because out of these features we are looking at during the designing of that structure, it is the diameter and the tensile strength of reinforcement that is usually considered during the design. So it's important that whatever diameter and tensile strength of reinforcement, characteristic strength of reinforcement that you adopt. It is important that you must work in conformity during construction. All right, that is the only way you can give that structure the required strength and stability. All right, so if there's any question as regards to what I have discussed so far, you can forward them across for further clarification. Thank you very much. Do well to follow this page if this is the first time you're coming across my video. Thank you very much and do have a wonderful day. Bye.